Hi everyone, Mr. Eric Kwa here, founder of Mr. Khemistry. Hope you're enjoying the videos that I've made for you specially. Remember to tap that like button and to click subscribe and to share with your friends if you found any of these videos useful or interesting. I look forward to seeing you around. Let's get started with today's topic. Hi guys, today I want to share with you about addition polymerization and condensation polymerization. Let's start with addition polymerization, right? So I want you to see a pattern here, right? You need to have a monomer which is unsaturated, which then can open up and become a polymer, right? So that's how we can get repeated units, okay? Thousands of repeated units. So here is one example, right? Let's take a closer look. So you have a monomer, which is ethene, being repeated. Okay, so how do we extend and repeat this unit, right? Is we basically draw it like side by side. Just put the H, align it like how we show the repeat unit. So basically what happens, right, is that you can see that the double bond actually opens up. Okay, the double bond opens up into connecting covalent bonds, which connects them. By right, you have another ethene, which will do the same thing. It will actually open up, and then they will form new bonds like these, and then the double bond disappears. You can see that the double bond disappears. This bond will disappear, and it will form a single bond. Okay, so the electrons, right, that are redistributed from the pi bond in the double bond will open up and form these two new connecting covalent bond to another two units of monomers. Okay, so they join up again and again, and basically you represents the polymer using these square brackets and alphabet N at the bottom. Okay, so that's example of a repeated monomer. Okay, let's see if we have other examples. So here you have three other example common polymers, right, that we use. I want you to zoom in and take a look at the monomer, right? Where is the difference here? So instead of having 4 hydrogen, right, now you have this methyl group on the first carbon. You can see very clearly that as you open up the double bonds, okay, the methyl group remains at the same position. Okay, it remains at the same position. So look at PVC. It's going to be the same thing, right? Chlorine, chlorine, chlorine. Okay, and then your double bond opens up, and then you form these two connecting bonds. Okay, how about styrofoam at the bottom? The unique group is your benzene ring, benzene ring, benzene ring. Okay, again, your pi bond opens up, pi bonds open up, opens up. Okay, so addition polymerization, right? You basically have one monomer with, say, one special group that is not H, and then the pi bond actually opens up into the connecting covalent bond to link them with other polymers. Okay, so essentially that is what you're going to be seeing. Okay, so what you are also required to know, right, is that if we show you repeated units of like a polymer, you're supposed to be able to deduce and isolate a monomer unit and draw it out for the examiner to see. All right, guys. So one of the other way, right, that they can give you the question, right, is that they can give you a polymer, show you a polymer chain with two or more different types of monomer. So I'm going to show you this example, which have a copolymer, which is called saran. Okay, so here, look at the polymer chain. Okay, so where can you identify is the difference? I hope you can see that there is chlorine here, 2 chlorine here, chlorine here, 2 chlorine here. So the repeatedness of this, I hope you can see. Basically, each monomer, right, you need to have at least 2 carbon. Okay, at least that's what we're taught in the syllabus. So you can isolate this as one of your monomer, and then this will be your second monomer. Okay, so the first monomer has 1 chlorine on the second carbon. The second monomer has 2 chlorine on the second carbon. Next up, guys, let's look at condensation polymerization, okay, which is represented by terylene and nylon in your syllabus. So terylene, right, is made up of dicarboxylic acid and dialcohol, so diol in short. Okay, whereas nylon is made out of dicarboxylic acid and diamine. Okay, the linkage, right, you got to be able to identify ester linkage, C double bond O, single bond O, and then imide linkage NH and single bond to C and C double bond to O, right? So the moment you see ester linkage, you know that it is formed from a polymerization of carboxylic acid and alcohol. Likewise, for imide linkage, it is between carboxylic acid and amine. Okay, so guys, we need to look at how they are formed in the first place. Why do we need diacid? Because you need to connect both ends, right? You need to connect both ends so that you can form a long chain with lots of these ester linkages. Okay, so I want you to zoom in, right, on this part here. Zoom in on this part. We're going to focus on this part here. You can see the way that they form the ester linkage, right, is taking out a H from the alcohol side of the diol and taking out a OH from the acid side of the diacid. Okay, so we literally just remove these 3 atoms, and we form a new bond that joins this carbon to the oxygen here. Okay, which carbon? This carbon to the oxygen here. Okay, so we literally just form, okay, we take out these 2, right, in the middle, eliminate the water, and then we form a new bond from carbon straight to oxygen. Okay, so here you have this is called a ester linkage. Okay, ester linkage. And if the question asks you to get back the structure of the diacid and the diol from the ester polymer, right, the polyester, what you're gonna do, you're gonna do the reverse, right? So I'm gonna blow this up a little bit. So let me use this ester linkage on the right here for clarity. So what we're gonna do, we're gonna cleave this new bond that was formed, and we're gonna add back the OH, and add back the H to the O. Okay, so in essence, right, we're adding back the water molecule that we took out earlier on. All right, so basically we're reversing this whole procedure, and we're getting back the diacid and the diol. Okay, so there isn't really anything much to it. You just have to practice this step, forming the ester and then hydrolyzing it back into its acid and alcohol components, right? Okay, so let me just scroll down a little bit. So the next kind of polymerization that we have, right, under condensation, we have amide linkage. Amide linkage, basically it is the same thing, except that for alcohol, right, for alcohol, in place of alcohol, we have this amine. Okay, so same thing, we're gonna just take out, this water, OH from acid and H from the amine, and then we're gonna just form this new bond direct from the C to the N. Okay, so here you can see that Okay, this will form us the amide linkage. This will be the new CN covalent bond. Okay, and if the question asks you to hydrolyze it back, okay, very simple, same thing that we're going to do. We are going to cleave this bond. We're going to add back the OH here. We're going to add back the H here. Voila. Okay, you get back the acid and the amine straight up. Okay, hope this helps, guys.